Have you ever had this awesome idea for an app or a game, but then you kind of get stuck? Like, how do you actually turn that thought into real working code? Well, today, we're going to pull back the curtain on that whole process. We're going to take a super simple idea, a Mischievous Genie game, and see exactly how it's built, piece by piece, using the fundamental ideas of modern programming. Let's dive in.
And this is the big question, right? How do you take a story, something like a genie invites a player to guess a number, and turn it into a living, breathing system of code where all the different parts just work together? This, my friends, is where the magic of object-oriented design comes into play.
Okay, so first things first, we have to stop thinking about our program as just one massive, intimidating wall of text. Instead, we're going to think in pieces. We're going to break the big problem down into smaller, much more manageable chunks.
And in the programming world, these pieces have a name. They're called classes. You could just think of a class as a blueprint for one specific job or one specific thing in our entire system. The key is that each class has one and only one clear, focused job.
So for our Genie game, we could spot three of these main pieces right off the bat. First, we're going to need a player class to hold the user's info, their name and age. Then, we obviously need a genie to be the star of the show. And finally, we'll make a GuessingGame class that does nothing else but handle the number guessing part. See? Each piece has its own clear job.
So, we have our pieces, our classes, but what's actually inside them? What are they made of?
This is such a great way to think about it. Every single class, every one of these building blocks, is really just a container, and it only holds two kinds of things: stuff it knows and stuff it can do. That's it.
And what's really cool is how this maps directly to code. The stuff a class knows is its data. We call these properties, things like a name or an age. And the stuff it can do, well, those are its actions, which we call methods. This is the actual logic, like a function to introduce yourself.
Our player class is the perfect example of this in action. What does it know? It knows the player's name and age. Those are its properties. And what can it do? It can run the introduce yourself action. That's its method. It's all bundled up in one neat self-contained package.
Okay, so we've got our building blocks. But a program with a bunch of disconnected boxes that never talk to each other, well, that's not very useful, is it? The real magic happens when we start connecting these classes so they can actually work together.
And our classes are going to talk to each other in two main ways. First, through method calls, which is basically one class just asking another one for some help. And second, through something called composition, which is a much tighter, more built-in kind of relationship. A method call is super simple. It's literally one object telling another object to do something. So in this line of code, our program is telling the Genie object, hey, run your greetPlayer method. And we're passing in the player object so the Genie knows exactly who to talk to. It's just a request for help. All right, now for that second type of connection. I want you to burn this phrase into your brain. The Genie has a guessing game. This little phrase is the absolute key to understanding composition.
So composition is all about this has a relationship. It's not a one-time ask for help. This is when one class is actually built using another class. It literally holds a whole other object inside of itself as one of its own properties.
And you can see this perfectly in our Genie class. Look, it has a property right inside it called game, and that property is a whole GuessingGame object. So the Genie doesn't need to know how to run a guessing game, it just knows it has a game object, and it can just tell that object to do the work. We call that delegation. It's super powerful.
All right, so we've seen the individual bricks, and we've seen the mortar that connects them. Now let's step back and take a look at the whole building, how it all comes together to make a complete system.
So here's the big picture, the main takeaway. We've defined our distinct pieces, our classes. Each one holds its own data and its own actions.
and they either talk to each other with method calls, or they're literally built out of each other through composition. That's our whole system in a nutshell.
And just like that, we've done it. We've taken that simple story about a genie and a player, and we've translated it into a living system of cooperating objects that know how to work together to get the job done.
Now, writing the code is one thing, but as our systems get more and more complex, just looking at hundreds of lines of code, well, it's like trying to understand a house by staring at a single brick. We need a blueprint. We need a way to see the whole structure.
So, the big question is, how can we actually get that high-level, bird's-eye view of our whole system? How can we see all the pieces and all their connections all at once?
Well, we use something called a UML class diagram. Seriously, think of this as the architect's blueprint for our code. It shows us every class, what it knows, what it can do, and exactly how they're all connected. You can see right here how the genie uses the player and how it has a guessing game inside of it. It's all there.
Now, if the class diagram is the blueprint, then this, the sequence diagram, is the movie script. It doesn't just show the structure, it shows the action. It shows the flow of communication over time. You can literally follow the arrows down the page and watch the conversation unfold as the program runs. It's amazing.
And this is why these diagrams are an absolute game changer. They help us get past just the syntax, the commas and the curly braces, and start to understand our program on a much deeper conceptual level. We start thinking about the design, the why behind the code.
This shift in perspective, from just writing lines of code to actually understanding system design, that is what it really means to think like a software engineer. This is the key to building not just little games, but huge, complex, and robust applications.
So we've gone all the way from a simple idea to a complete system design. You now have the tools, the way of thinking to turn your own ideas into code. So the only question left is, what are you going to build?